Okay, hi everyone, and welcome to Math 2 for 2. So let's discuss about the symmetric functions. So to be specific, what are odd and even functions and how do we integrate odd and even functions? So let's begin with even functions. So an even function is a function wherein if we split this function into two, in the y-axis, it will be symmetrical. So basically, an even function is a mirror image, no, in the y-axis. So one example of that is a parabola or a parabolic curve with a vertex at the y-axis. And then its mathematical expression or its mathematical relationship is we have f of negative x is equal to f of x. Now for odd functions, we have a slightly different way of looking at odd functions. Well, this is still this is analogous to even functions. This is still a mirror image of our function, but instead of just the y-axis symmetry, if we cut this function into half and then we rotate this function upwards, no? So there is flipping in this x-axis, and then we flip this again with the y-axis, then we can form our odd function. So there is symmetry with regards to folding the x-axis and the y-axis. So comparing this to even functions, we can fold this once, and this will be coincident, no? But for odd functions, we have to fold this twice. So first is for the x-axis and second one is for the y-axis for it to be coincidental, no? Meaning magkapatong or on top of each other. Okay? So the mathematical expression of an odd function will be f of negative x is equal to negative f of x. Now, with regards to their integral, if let's say we have to find the integral of an even function at a symmetric portion of the function from, let's say, a and the negative value of a, so a could be any number, no, let's say 10 and negative 10, 5 and negative 5. So assuming a is our length in the x-axis and negative a is just the negative portion of that, then the area that we are trying to find, which is also the integral, will be this. Now we can find the area of uh, this function under the curve, and we will have this integral, no, this definite integral. But to make things simpler, instead of finding the area of these two things, no, this two area, we can just find one of this, no, and then multiply this by 2 since they are symmetric, no? So let's say this is from 0, no? We start from 0 here. This is the symmetry point. Then the integral or the area under this curve represented by this, so from negative a to a, is also the same as finding this integral from 0 to a. So we can find the area of this and then just multiply it by 2. Okay? And alternatively, we can also do the same for this portion, no? So we can find the area of this and then multiply it by 2 to get this whole area. So we start here with negative a to 0. So this will be from negative a to 0. And then multiply this by 2. Okay? And this will be a relationship of the areas of our even functions. Now, for odd functions, we know that with odd functions, no, if we flip this with the x-axis, we will have this curve, right? If we flip this in the x-axis, and if we flip this again with the y-axis, this will be coincidental. That is the definition of an odd function graphically. If you want to find the integral of an odd function, which is represented by this, so from negative a to positive a, then we're trying to find the area under the curve with relations to the x-axis. So the area here will be, so since this is under x-axis, the area will be negative, right? And this will be positive. So therefore, the sum of their two areas, assuming they are symmetrical, no? So odd functions area are still symmetrical, then we could say that the sum of their area will just cancel out. So a positive A and a negative A, if we add these two, so A plus negative A, this will be equal to 0. Therefore, the integral of an odd function is basically just 0, no? From a symmetric point from negative A to A. That is the simplest integral that you can evaluate. Now, let's have an example of this. So evaluate the given integrals given it is a symmetric function. So if it is a symmetric function, it could either be an odd or an even function. So we want to first check if our function here is an odd or an even function. And you can see that the limits are also symmetrical. No? So we have positive of 3, negative of 3. Therefore, we could try either this definition or this definition. So if it is an odd function, it will be much easier. So let's check if this is an even function or an odd function. So we have f of x. So f of x here is equal to this function, which is just x. So how do we now find f of negative x? So we need this for our relationship, right? So basically, we need to substitute negative x to this x. So therefore, we have to change this x to negative x. So x into negative x. Therefore, f of negative x is just negative x. And as we can see here, the relationship of this two, ano? If f of x is equal to f of negative x, then this is even, no? And if f of x is equal to negative f of negative x, then this is odd. So which of the two definition is correct here? So definitely not this one. So probably this one. So as we can see, we have x here. And then this one, this is equal to the negative of negative x. Right? So that basically we have f of x is equal to negative of f of negative x. Therefore, this is an odd function. So we know that this is an odd function. Therefore, the integral of this function from negative 3 to 3, okay, is just 0. Yan. Okay? So that is the quickest way to do this if you know that it is either an odd function or an even function. So one way to do this again, assuming that you do not know yet the odd and even functions evaluation, you can try integrating this directly, and this will be still, or the evaluation of this integral will still be 0. If you try, let's say this x squared over 2, and then substitute this 3 and negative 3 here, this will still be 0. Okay? So another thing about this, another example, we have the integral of x squared dx from negative 5 to 5. So how do we evaluate this? Again, this is assuming that it is a symmetric function, so it could be either an even or an odd function. So how do we check if it is an even function or an odd function? Yeah. So we have this relationship of f of x and f of negative x, right? So our function here, guys, is x squared. Okay, so this is a symmetric function. We have the same limits, just a positive and a negative value of our limits. So to find again f of negative x, we have to just substitute negative x to this variable x. So we will swap x into negative x. Therefore, f of negative x will be negative x. So we just substitute this negative x to this function here. And then if you simplify this, this will be, so square this negative x squared, this will become positive. So as we can see here, these are equal. We can say that f of x is equal to f of negative x. So this relationship is an even function. So what is the integral of an even function? No, we can change this one if we want to. So this is an optional thing to do, ano? So we have x squared dx. So we could evaluate this integral in this way, or we could evaluate this in this way from 0 to 5 x squared dx, or we could also do from negative 5 to 0 of x squared dx. Okay, so we're just finding the half of the area and then multiplying this by 2. Same goes for this other one, from the left hand side. So I'll just utilize this one. So this will be equal to 2, the integral from 0 to 5 x squared dx. So the integral of this is x cubed over 3. Sorry, we have 2, forget the 2. You have x cubed over 3 evaluated from 0 to 5. Okay, so this will be equal to, substituting this 5 and the 0 here. Okay, we can just factor out this 2/3, guys. So just factor out the 2/3 to make things quicker. We have x cubed, so this will be 5 cubed minus 0 cubed. So this 0 cubed is just 0. Therefore, 5 cubed is equal to 125. So 5 times 5 times 5. So this will be 2/3 times 125. Or in other words, this is 250 over 3. Okay? So that will be your integral. If you try integrating this directly, guys, you must have the same answer. Or if you try evaluating this one, it must be the same with this one. You can try this at home or during class. Okay, so that will be that will be everything about the Newman functions. If you have any questions, just ask me in class. So again, if we know that it is an odd function, the integral is just 0. If the function is an even function, the integral will be just a simplification. You could evaluate this from the half side and then just multiply this by 2. Okay, so moving on, we have the change of limits. Ayan. So if we could remember, we utilize use substitution for evaluating integrals. And the problem, is that we have to change the variable u back into its original variable x. Now, alternatively, what we can also do, there's an optional way of evaluating definite integral with integration of u substitution using the change of limits. So change of limits and u substitution are related to each other. Okay, so let's just do this directly. So we want to integrate this function. And to integrate this function, we have to use the u substitution. So we do not have an integral table that could evaluate this directly. So we have to use u substitution. So using u substitution, we have u as 4x plus 1. Okay. And then finding the derivative of this function or this equation. So the derivative of u is du. Derivative of 4x is 4dx. The derivative of 1 is 0. And then simplifying this, solving for dx. So we want to change also the variable of integration dx. So this will be dx is equal to du over 4 again. Okay. So what's next here? Changing this up, we have the integral from 0 to 2 of the square root of u, and then multiplied by, so dx is now equal to d over 4. So d over 4. And then simplify this. So we have this constant. We can factor out this constant. So this will now be equal to 1/4. The integral of from 0 to 2 of the square root of u du. So the square root of u can be also represented as u raised to 1/2 and then multiplied by du. Okay. So using just the power rule, we can evaluate this integral. This will be equal to u raised to 1/2 plus 1. So add this by 1. So this will be u raised to 3/2. And then whatever is the exponent here will also be the denominator. And then since this is a definite integral, we don't need to add c, but instead we have to write this evaluation from 0 to 2. Okay, so let's simplify this one. So we have here, so find the reciprocal now. So we have 2 over 4 times 3. And simplifying this, we can cancel this out. So this will become 1, this will become 2. Therefore, this is equal to, I'll just write this down as 1 over 2 times 3, which is 6. And then u raised to 3/2 evaluated from 0 to 2. Okay, assuming that we do not know the change of limits, no, we can just change this u directly to 4x plus 1. And then after that, we can substitute this 2 and this 0. Now, assuming that we have to change this with 4x plus 1 first. So what you cannot do is do this directly. You should not substitute this 0 and 2, no? So that is wrong. If you substitute this 2 and 0 for the evaluation of this definite integral, since the 2 and 0 are with regards to the variable of x, no? So what the change of limit says is that we have to change the limits if we also change the variable. So there are two ways to this though, at looking at this. We could either change this variable and then we substitute this limits, or we can let this be the new variable, but we have to change the limits. So let's change the limits here, no? So how do we change the limits? The change of limits here will still be the same equation that we used for our u substitution. So for the upper limit, we have, let's call this g of b. Okay, so we will substitute the value of 2 to this x. So this will be 4 times 2. So this one, no? 4 times 2 plus 1. So this will be equal to 8 plus 1, which is 9. And then the lower limit, we have, again, this equation. We have 4 times. So this will be 0 plus 1. Therefore, this will be 1. Therefore, the new limit here, we have from 0 to 2. So therefore, this will be 1 to 9. And then now we could substitute the value of 9 and 1. So this will be equal to 1/6 9 raised to 3 halves minus 1 raised to 3 halves. Okay? And how do we evaluate this? So evaluating this, we have a simplification of that. We just want to find the square root of 9 and then cube the square root of 9. And then the value of 1 raised to 3 halves. So any exponent here, if your base is 1, this will always be 1. Okay, so what is the square root of 9? So square root of 9 is 3. So therefore, we are trying to find for the cube root of 3. So this will be equal to 1/6, 27 minus 1. Therefore, this is 26 over 6. Simplifying this, we have 13 over 3 as our final answer. Okay, so alternatively, what we could do, no? Okay, so this is the final answer when we use the change of limits. This is the change of limits, guys. But what if we do not know the change of limits? Would the answer still be the same? So going back to the integration from this, or sorry, not the integration, but the evaluation of the integral, of the definite integral from 0 to 2. So going back to this, instead of changing the limits, what if we just change this? So we can change this u into, we have 4x plus 1 raised to 3 halves. So at this point, we can substitute the 2 and the 0 here. So this will be equal to 1/6. We have 4 times 4 times 2 plus 1, and then raised to 3 halves, minus we have 4 times 0 plus 1 raised to 3 halves, and then simplifying. So as we can see here, this will still be 9 raised to 3 halves minus 1 raised to 3 halves. So we will arrive at a similar step that we did, no? So therefore, the evaluation of this will still be, this will still be 13 over 3. I will just skip the step since we already solved this 1. Okay, so either, again, you can change the limits or you can change the variable to its original variable. You cannot substitute this directly if you change the variable, or that is wrong. Okay, so that will be all for today. See you guys in class.